Welcome to Brain Vision.
So this question is asking us about the importance of spin when we are writing electronic configuration, and it wants us to explain in terms of the Pauli's exclusion principle. So for us to understand what I'll be describing, it's very important that we know what Pauli's exclusion principle is. So there are three rules that are important when writing electronic configuration. The first one is the Hund's rule, and the second one is the half-bar rule, and the third one is the Pauli's exclusion principle. So I will just quickly go over the first two rules. So the Hund's rule is also called the rules of maximum multiplicity, which means that you should fill the orbitals in such a way that you have the least number of unpaired electron, which means you should fill singly first before you start to pair the electron. So that is what the Hund's rule describes. And then the half-bar rule is also called the rule of building, in which you fill orbitals with low energy first, and then you ascend to the orbital that is next in energy, and then you keep going up until you completely fill the orbitals. Uh, so, which means you're climbing in terms of energy. Then the last rule, which we'll be using in this question, is the Pauli's exclusion principle. And what this rule is saying is that there are no two electrons in an atom that can have the same value for all the four quantum numbers. So you should know that there are four quantum numbers, and they call the principal quantum number, the subsidiary quantum number, the magnetic quantum number, the spin quantum number, and one of them is also called the azimuthal quantum number. But basically, they are represented with N, L, S, and M. So N is the principal. L describe N, which is the principal, describes the shell. L describes the orbit or the orbital angular momentum or the orbital. S describes the spin, and M describes the multiplicity or the orientation of the electron. Let me just put multiplicity out. That's something else for this, another topic for discussion. So there are four quantum numbers. So what Pauli's exclusion principle is saying is that no two electrons will have the same value for all these four quantum numbers. So an electron, two electrons can be in the same shell. They can be in the same orbiter. They can have the same magnetic quantum numbers, but they cannot have the same spin quantum numbers. And what is spin? Spin has to do with the orientation of an electron in the magnetic field. So there are only two spins that are known for electron. So we have the positive spin, which means pointing up. So this is called plus half. And the negative spin, which means pointing down, and this is called minus half. Okay, so those are the two spin quantum numbers. Okay, so why is electron spin important when writing electron configuration? So the electron spin describes the orientation of the spin or the spin quantum number. Is essential to Pauli's exclusion principle, because without the electron spin, we cannot satisfy the Pauli's principle for two electrons on the same orbiter. So if you have an orbiter, according to Pauli's exclusion principle, the electron, if you have two electrons in an orbiter, the electrons can only uh, pair up and spin in opposite direction. That is, they can only have a plus half and minus half spin. You should never have a situation where you have 2 plus half or 2 minus half. Okay, this is a no. This is the right way. The electrons should always have opposite orientation in the same orbiter. So that is what the Pauli's exclusion principle is describing, and that is why it is important.